Today, we are looking at a genuinely groundbreaking idea in AI. Seriously, what if, instead of us teaching an AI, it could just create its own curriculum? What if it could teach itself to get better? Well, that's the core idea behind the new framework we're going to dive into. So picture this, a future where AI isn't just a chatbot you talk to, but a real proactive agent that can actually do things for you. I'm talking complex, multi-step tasks, booking your travel, managing your work calendar, even arguing with customer service on your behalf. That's the huge promise of AI agents. But to get to that amazing future, we've got to solve a really fundamental problem first. There is a massive roadblock holding these AI agents back, and it's stopping them from becoming as powerful and as reliable as we really need them to be. And that brings us right to the heart of the issue, what's being called AI's training bottleneck. So let's break down exactly what this roadblock is. Okay, so how do these agents learn right now? Well, to get good at complex stuff, they need a huge library of practice problems. And here's the catch. Every single one of those problems has to be created and labeled by a human. It's incredibly slow, it is super expensive, and it just fundamentally doesn't scale. I mean, we could never hire enough people to create the millions of practice problems needed to train a truly powerful AI agent. This huge limitation leads to a really fascinating question. What if we could just remove the human bottleneck entirely? What if an AI could just create its own curriculum? And that right there is the core of the research we're exploring. It's a framework called self-challenging, and it's all about the AI generating its own training data. Okay, so here's how this whole system works. The AI basically splits itself into two roles. On one side, you have the challenger. You can think of this as the part of the AI that's like a teacher creating a test. It explores a digital world, its tools, and it designs a brand new, challenging practice problem. Then it flips roles and becomes the executor. This is the student side that has to take the test. It gets the task the challenger just made up and tries to solve it, learning from every single success and failure along the way. But this, of course, raises a pretty obvious question, right? If an AI is making its own homework, what's to stop it from just making up impossible tasks or super easy ones or just nonsense? How can you guarantee that any of this self-generated data is actually any good? And this is where the most clever part of this entire framework comes into play. The secret ingredient is a new format for defining all these tasks called code as task. Code as task, or CaT for short, is this really structured way of packaging every single self-generated problem. So instead of just a simple instruction, the entire task, the rules, the goals, the way you check the solution, it's all written as executable code. And this is the brilliant part. Because it's code, a computer can automatically and with perfect reliability check if the task was actually solved correctly. No ambiguity. Every one of these CaT packages is made of 4 critical pieces that all work together to guarantee quality. First, you have the simple instruction in plain English, but then comes the really clever stuff. You have a verification function, which is just a piece of code that acts as an automated judge, checking if the solution is correct. To prove the task isn't impossible, the AI also has to provide a working example solution. And finally, to make sure the judge is tough enough, it includes failure cases, basically examples of wrong answers that should be rejected. All 4 of these things have to work perfectly for a task to be accepted into the curriculum. This 4-part structure is basically a super powerful filter. It automatically weeds out all the bad tasks. If the solution provided doesn't work, or if one of the failure cases somehow passes the test, the entire task just gets thrown out. This whole structure ensures that every single practice problem is actually doable, checkable, and genuinely useful for learning. Okay, so the theory is really solid, but does this thing actually work in practice? Let's get to the results, because this is where it gets really impressive. So, the headline number from the research is a 95.8% average relative improvement in the model's success rate. That is a massive leap in capability. Now, let's look at a concrete example to see what that means. They took a model, Llama 3.18 billion, and on a set of really complex tasks, it started with a success rate of just 12%. But after it was trained on its own self-generated tasks, its success rate nearly doubled to 23.5%. And I really cannot stress this enough, this is the most important part. That huge performance boost was achieved using 0 human-created, human-labeled training data. Absolutely none. The AI did all of this completely by itself. It created the curriculum, it took the tests, and it got smarter all on its own. So, let's zoom out. What's the big picture here? What does a breakthrough like this really mean for the future of AI? All right, so what are the key things to remember? First, this gives us a scalable way to train powerful AI agents that completely gets rid of the human bottleneck. Second, that code as task format is the key, the reliable way to make sure the quality is there. Put those together, and this brings us a giant step closer to truly autonomous, self-improving AI systems. And it could dramatically speed up the day when these agents become actually useful in our real everyday lives. And that leaves us with a pretty fascinating final thought, doesn't it? We've just seen an AI that can create its own lesson plan and measurably get better all by itself. So if an AI can effectively teach itself, you have to wonder, what's the limit? Is there one?